To grasp the concept of substitution in integration, we delve into the realm of simplifying integrals using a powerful technique. Through the method of substitution, we replace complex parts of the integral with a single variable denoted as u. This strategic choice of u is pivotal, often aligning with a segment of the expression that can be differentiated to integrate seamlessly. Initially, we select u as 3x2 plus 2. By deriving u with respect to x, we discover du as 6x dx. This derivative sets the stage for transforming the integral into a more manageable form. Transitioning to the next step, we reframe the integral in terms of u, converting it into u4 du. This pivotal maneuver becomes achievable due to the initial substitution we implemented. Advancing further, we delve into integrating the simplified expression, yielding 1 of u5 plus c, where c symbolizes the constant of integration. Subsequently, we reintroduce u into the equation, culminating in 1/5 3x squared plus 2 core 5 plus c. As we streamline the expression, the significance of substitution shines through, making intricate integrals accessible and comprehensible. This foundational understanding of substitution plays a vital role in mastering integration techniques, especially when tackling intricate expressions involving powers, trigonometric functions, and exponentials. Substitution emerges as a valuable asset in the landscape of integral calculus, offering a systematic approach to effectively address complex problems. By practicing diverse examples and refining the skill of identifying suitable substitutions, you can elevate your proficiency in integration techniques. Immersion in the intricate world of substitution and its integration applications culminates in reinforcing our comprehension through a thought-provoking practice quiz. This endeavor solidifies theoretical knowledge into practical problem-solving